So I've called this session Big Data, what social scientists can, can't and should do. I'm going to talk about some of the ways that I've used big data to do political science, and hopefully it'll give you some ideas for how you can do the same. We need to define our terms first of all. Big data has been defined as the 3 V's: volume, velocity and variety. IBM had a 4th V to that, which is veracity. And Dykes for Oracle says that the derivation of value from traditional relation database driven business decision making augmented with new sources of unstructured data. Such new sources include blogs, social media, sensor networks, image data and other forms of data. I've highlighted those there because those are the things that I use in my research to answer old political questions. So that's the whole idea here. We're using new types of data to answer old political questions. One of the ways we do that is through the use of what we call proxies. If we want to measure something but there isn't a way of measuring it, then we measure something else instead and use that as like a surrogate for the thing that we wanted to measure. So here I was doing some analysis with Twitter, and I found curiously that if I look at when people use Twitter in a day, then we can do cross-national comparisons of when people get up in the morning and when they're working hardest through the day. And so I ran this piece, and the website Medium picked up on it. Yeah, do Americans wake up earlier than people in France and South Korea? To which somebody promptly responded, people are paid to write this kind of bullshit. Incredible. Actually, I wasn't paid anything to do it, but whether you think it's what that person describes it as is another matter. Another thing that we do with big data is we have to stitch data sets together, and in doing that we can find new things. So here on one side I've got the EU referendum for the UK to leave the EU, organised by constituency, and then on the right hand side there I've got the anti-Trump petition, the petition that was launched so that Donald Trump wouldn't be allowed to come into the UK. And what do you know? We find a very strong relationship between the number of people in a constituency who wanted to remain in the European Union and then the number of people in the constituency who signed the petition to tell Donald Trump that he couldn't come to the UK. We can do these things with data, and it's stuff that we couldn't do in the past. Or here, finding a relationship between how dense the infrastructure is in a constituency and the way that the people vote in that constituency. Again, this is stitching together data sets to make new findings. So today, 3 projects I've been working on, one on Africa, one to develop this infrastructure measure called Infra, and another, a tool that helps you to do all this called Spatial Grid Builder. So first, the Africa research is collaborative research. I've been working with my colleagues Ismeni Gazelis at the University of Essex and Henrik Erdl, who is now the director of PRIO, the Peace Research Institute in Oslo. And we've been looking at environmental factors and conflict in Africa. Reason being, academics and policymakers are increasingly concerned about the relationship between environmental factors and human conflict. There is an expectation that climate change is going to lead to things like resource wars, population displacement and all of those sorts of things. That's the expectation both in the policy community and in some of the literature. The Pentagon has said that climate change is a threat multiplier. The UN has called for the creation of green helmet peacekeepers, and the 2007 Nobel Peace Prize was given to the IPCC. But there's not much science out there actually linking climate change to human conflict. We know that human-induced climate change is occurring, but whether that then links to conflict is another matter. So, to test this, we're going to use a dataset called ACLED, the Armed Conflict Location Event Dataset, which gives us geospatially coded data on conflicts. When the project started, it was just looking at Africa. It has expanded to other parts of the world now. But for this project, we are looking at Africa, and we've built what I call a spatial data grid, wherein we divide the continent of Africa into lots of tiny little squares that are about half a degree each square. Within each of those squares, so take every single one of those squares, and within each one of them we're going to have how many incidences of conflict were there from 1997 to 2010, and we have annualized data on this. Is it an urban or a rural area? What's the level of desertification, population level, rainfall, drought, Infrastructure, is it in sub-Saharan Africa? How far is it from the capital city? How far is it from the border? How rugged is the terrain? Then, in addition to that, we've got what we call the state level control variables. So these are not the geospatially coded to the grid, but nevertheless you have to include state level controls. They are gross national income, political stability, government effectiveness, voice and accountability, and similar measures from Polity 4 in terms of democracy and autocracy. Again, Chiba, Gandhi and Vreeland have another measure that does the same thing. Food production and state population as a control. Our conflict data, so I mentioned that one source of the conflict data is ACLED, the Armed Conflict Location Event dataset. We've taken all of the types of conflict variable that they had and recoded them to two types, a conflict event and a low intensity event. And I can explain this in the seminar. ACLED data have 3 levels of geographic precision. We've gone with the most precise that we could get. In addition to this, as a robustness check, we're using another conflict dataset called SCAD, the Social Conflict in Africa dataset, put together by Aydin Saleh and Cullen Hendricks et al. On which we've taken the first 6 types of demonstrations, riots and strikes, because that's what we're interested in. So for each cell we look at how urban or how rural it is, and what we find in Africa is actually there's not much urban territory as a percentage of the continent as a whole, so we expand our definition of urban area and come up with the notion of the peri-urban area, rather like a donut around the centre of a city. We include measures of desertification, that's how. Gridded population data, so we're not just using state data, although we use that as well as a control. Rainfall data, which we have going back to 1979. The ruggedness of terrain, one that I can explain in the seminar there. We're using that measure, and if you're interested in it, those are the most rugged parts of the world. The infrastructure proxy, which I will explain how we've constructed that in a moment. And our findings at the end of all that, and we've been working on this for about 8 years now, and we've just had our second revise and resubmit with political geography, so I desperately hope it's going to be in print soon. But proximity of drought has no direct effect on urban social unrest. High population growth based on migration from rural areas increases the likelihood of urban unrest, and urban unrest tends to occur in the urban outskirts only, this peri-urban area that I was talking about. Okay, how we constructed that infrastructure variable? Well, first of all, we didn't have an infrastructure variable, so a lot of researchers have used something else. They've used something called, well, I'll come on to it in a moment. Let me get to my slides. Right. It's been used in biodiversity loss, malnutrition in Africa, desertification, HIV/AIDS. You can see all of those there, but it's all based on the digital chart of the world, which was put together by an organization called the ESRI. It's structured like this. It divides the world up along those lines. Why would people use it? It was described as the first comprehensive global data set, providing global coverage, and is now one of the best and most widely used public available road network data sets. Well, I would disagree with all of that. The roads data in the digital chart of the world are known to be incomplete for a number of countries. It has some very old data. It's actually a declassified US military project across 4 decades, and I'll explain more on that. Smith and Langas in a survey find that the DCW is useful if that's all that's available. I'm arguing that that is overstating the use of it. It's not useful in that regard at all. Reasons being, if we look at the road data, first, Chad Sudan there, roads that disappear at the border. Same thing in the equator, roads disappearing at the equator there in DR Congo. Or in Somalia we have grids that I don't even know what they are. They're certainly not roads. How was this thing created? Well, the digital chart of the world, as I said, was created by the ESRI. Ultimately, it draws on 4 countries' mappings from military maps. They are the US Defence Mapping Agency, UK Ministry of Defence, Australia and Canada. Now you might think, military maps, conflict research, perfect. No. They were created for pilots or navigators flying at medium and low altitudes, or low altitude high speed operations. They weren't created to make an accurate or complete set of road maps. The apparent movement of the ground is rapid and causes blurring, therefore the selection of ground features should be based on the requirement for rapid visual representation. So, cartographers were systematically instructed to exclude roads in the more dense areas, and so the less dense areas have more roads represented in the DCW. People are using this thing as a measure of infrastructure. It's not. It's almost the opposite. It's useless. So, as an alternative, I created this thing called infra, which is an R package. If you're familiar with the R statistical programming language, then it's freely available through that as the package infra on CRAN. It works like this. It downloads thousands and thousands, or millions if you let it, of map images from Google, Bing, Open, and actually from Sina Weibo maps as well. I forgot to put that one in. And it measures how complex they are. The more complex, the more infrastructure. And we see here, we're looking for the three there, the Google, Bing, and Open. We have 42K, 23K, 47K for Tokyo for all of them. And we find that the complexity of the image decreases as we go into less metropolitan areas. So Little Rock, Arkansas there, or the same thing for Timbuktu. We can use that then as a proxy of our infrastructure, because if we're building a grid like we did in the Africa project there, then we can create these highly detailed, high resolution infrastructure measures. They look like night light images. They're not. They're much more precise than that. But yes, that's for a project where I was with a broad definition of what Asia was. Those are the night lights. As you see, it's a rather more coarse image. It's just not as detailed. And then a more narrow definition of Asia using even higher resolution data there at 0.05 degrees per grid cell. And that's the night lights for Asia. And yeah, it's useful for seeing things like, for instance, where North Korea starts and South Korea ends. There we go. And Bangladesh there as well. Right, now, if you don't use the R statistical programming language that I was referring to a moment ago, then you can still do spatial data analysis using this tool I built. If you've got a Mac, it won't work, sorry. I built this on a PC, and you can download it for free from, I'll give you the URL in the seminar because I can't remember it at the moment. SourceForge, that's the one, SourceForge. You can download it from SourceForge. It's called Spatial Grid Builder. It will help you to build a grid. You can plug your data in and then do that spatial analysis, and it works like this. You have a nice web interface, a nice graphical user interface, and you'll build a new grid. You'll tell it the resolution of the grid that you want and the bits of the world that you are interested in. So, for the sake of argument, we'll pick Africa. We enter those coordinates there, and that we can view that spatial data grid. At the moment, there's nothing in it. All that we have is a grid number, latitude, longitude, and the area of that grid cell, which will vary as you approach the poles. Then we can populate it, first of all, with a land mask. That then gives us what we call a dummy variable, a binary. 1 if there is land, 0 if there is not land. We can visualize that. And what do you know? There's our 0.5 degrees per grid cell map of Africa and surrounding areas that we're interested in. Okay, what next? We might be interested in a particular state. So we add a state mask. Here I'm going to put Namibia in, and then it's identified again with what the dummy variable, which bits are Namibia. Then we can populate with all these other data, including state IDs, ACLED, those conflict location event data, other conflict data, distance, spatial lag, mountainous terrain, infrastructure, night lights, rainfall, infant mortality, tree cover. It's all in there. You just click the button. It'll take a while to process depending on how high resolution you run the thing, but they are in there. But you can import your own data as well, and that's why it's useful. Your point data, your radial point data, your polygon data, or your raster data. Based on that, and so I presented earlier the Asia Broad thing, and here we have Asia Broad and Asia Narrow with the infrastructure and so on, and tree cover, night lights, ruggedness. From all that, we get a regression table, which is well beyond the scope of this video to explain, but I can talk about that in the seminars. But we can link our spatial factors to conflict or any other dependent variable that you are interested in. So, summary. A new data revolution is underway. It's only just beginning. As social scientists, that is exciting. It opens up lots of new opportunities for research. Hopefully, it will give us more evidence to answer old questions. It's not as straightforward as we think it is. We still need to use conventional methods, but my bit of evangelism here, we really need to teach our students how to do this stuff. It's not only interesting and important, but it will give entirely new skill sets that can complement social science background and help you to get exciting jobs. Anyway, let's talk about that in the seminar.